So this is finishing up the notes that I started in class today. So the next topic is, or not next topic, but talking about personal probability. So don't let something that you're thinking should be get confused with how we actually figure out what the probability is, okay? So we're thinking about the probability of rain. Well, we really, in a way, it's a judgment call. It probably will rain tomorrow. It's not really what you want to say with that. Okay, so be careful of not allowing what you think should happen interfere with figuring out what the probability should be. Okay. All right, so the probability of an event, this notation here, the P, it represents the probability. The letter A represents that particular set. So if you see in your notes, I have the letters A, B, and C. So those represent different sets, or like it could be, A could represent hearts and B could represent spades, something like that. So in the numerator is the count of all of the outcomes in A, and it's divided by the count of all of the possible outcomes. So before, when I talked about sample space, that's what is going in the denominator. So how many times can I get A out of how many times is something possible? So the formal probability rules, there are 5 of these. So first of all, if a probability is 0, then the event will never occur. So probability is always between 0 and 1, and inclusive means that it includes 0 and 1. So that's the first rule. Second rule is that the probability of the set of all possible outcomes must be equal to 1. Okay, so the probability, what you need to remember is that it has to be between 0 and 1. It can't be over 1. 1 really represents the 100%. Okay, so if there is a probability of 1, that means that it is 100% certain that it will happen. Third one is talking about complement, and you'll see complement written a variety of ways. So the other way you'll see it, A, and then this it looks like an apostrophe. You also see the letter A, the letter A written with a small c, and that means that it's the complement, okay? So the probability of A, the probability of something happening, is 1 minus its complement, and the complement is the probability of something not happening, okay? So we have some examples later to go through that. Okay, so a complement means that it's the probability of something not happening. So if I add up the probability of it happening with the probability of it not happening, it better equal 1. It has to equal 1. Okay, so before I do the fourth rule, the next topic, or the next, I guess, subject that, or yeah, what I need you to hear next is talking about disjoint or mutually exclusive. I talked about independent before, and this is something that we will talk about more. So there is a difference between independent and disjoint. So disjoint or mutually exclusive means that 2 events cannot happen at the same time. There's no way that I can pick a heart and a black card because all of the hearts are red cards. So no card is both. So the probability of A and B is 0 because they both can't happen. Okay, so different than independent, where one doesn't affect the outcome of the other, disjoint means that it can't happen at all. Okay, so the general addition rule, and we will talk more about this in chapter 15, but for right now, you need to focus on 2 disjoint events. So if 2 events are disjoint, this is the notation, and we're looking for one occurring or the other. So the important word here is or. So one event occurring or the other one occurring, and disjoint is the other word. Okay, so 2 events, if they're disjoint and one is occurring or the other one is occurring, then we can just add their probabilities. And this means union. So you've seen this before, probably in geometry or in algebra 2, where we say one and the other one is the union. So we're taking one set and adding it to the other set. Okay, so one or the other. Okay. All right, so for multiplication rule, here the 2 words that are important are that it's independent and. Okay, so and is what is most important. With or we add, with and we multiply. But this general rule only works if the 2 events are independent. Okay, so this is the intersection symbol that you've seen before. So if we want A and B, find the probability of A and B occurring, it's the probability of A occurring times the probability of B occurring. Okay, so and independent events. Okay, so beware of probabilities that don't add up to 1. Don't add probabilities if they're not disjoint, and don't multiply probabilities if the two events are not independent. Okay, and don't confuse disjoint and independent. So disjoint can't be independent. And again, I will spend more time on this so we understand those two. Okay, if two events can't occur at the same time, then they have to have an association with each other in order to even talk about probability. Okay, so you can't get an A in the class and a B in the class is what the example is here. Okay. All right, I'm going to, so that's going to be the end of this video. I may come back to these questions. That'll be the end of this video.